Hi, Jackson.
Hello.
How are you doing tonight?
I'm good. How are you?
Good. So you got a quiz on Tuesday?
Yep.
Okay. What are we working on tonight?
Uh, Graphing trig functions.
Okay.
And then let me send you these
Okay.
pictures.
We can certainly verbalize graphing of them. What will be tough to do will be coming up with the function looking at a graph. That would be tough to verbalize.
All right, the first one's sent.
Okay. Match the function with its graph. Well, the easiest way to do this is probably to look at the functions and try to figure out what the graph of that function is.
Yeah.
Okay. We recognize these are either secant or cosecant.
Yep.
This looks like either negative tangent or cotangent. This looks like secant or cosecant. This looks like positive tangent or negative cotangent. In other words, just in general.
Yeah.
Now we have to figure out which is which. Well, let me draw a picture here because let's start with the sine curve. What's the reciprocal of the sine?
Yeah, 1 over sine.
No, what's the reciprocal of sine?
Oh, 1 over cosecant.
Which means that when sine is equal to 1, cosecant has to be equal to 1. Which means they both have to share that point. And when sine is negative 1, cosecant has to be negative 1. So they also have to share this point. So the cosecant curve is the one that sits on the tops of the sine. Tops and bottoms. So that's kind of the way I graph it. I always relate everything to sine and cosine. So this would be y equal cosecant of x. Now let's look at what they've got. This first one is y equals secant of x over 2. On this cosecant curve that I drew, how's this labeled? What is that label right there? It's 2 pi. In other words, the period of the cosecant function is 2 pi before it starts repeating again. And it also has vertical asymptotes, which makes sense because whenever the sine is 0, cosecant is undefined. You can't divide by 0.
Yeah.
So these vertical asymptotes go every pi, but the period of the function is 2 pi. Well, this first function that they talk about down here is secant of x over 2. So let's see if this could be that. In other words, secant of x over 2. First of all, what is b? And meaning, what is the period going to be of this function right here?
1
Pi. Right? Because b is what?
Well, b would be 2 pi over 2 pi, wouldn't it?
Well, b is 1/2. Correct?
Uh-huh.
So period is 2 pi divided by 1/2, which is 4 pi. So when you stick a fraction in front of a trig function like this, it stretches it out. So if this was 4 pi right there, then I could say that would be the cosecant of x over 2. Because it would have the right period, 4 pi, and it would be the cosecant because it's sitting in the right place. Well, let's go see if we can find the secant curve that has a period of 4 pi. Now, what are these numbers down here?
It's just the scale's just 1, 2, 3, 4,
Okay.
and then
Okay.
1, 2, 3.
So, what curve does this look like? Well, let's back up a step. I'm making this harder than it is. That looks like the cosecant curve, right? That I just drew. It's in the right spot. Only it's this one over here instead of this one. But it's still one period of the cosecant curve. And it goes from 0 to, what is that number?
That's 3.
3? That sounds like pi to me. Oh, no, not necessarily. But it goes from -3 to 3, so it doesn't quite go -3 to 3. If that was -3.14 and that was +3.14, then I could say that the period of that thing is pi. 2 pi, excuse me. It would be 2 times 3.14, right, to get from here to here?
Yeah.
Okay. Well, this period doesn't appear to be 2 pi, it appears to be 6. If it's going precisely from -3 to 3, then I would say the period is 6. Well, if the period is 6, what is b?
1/3 1/3 pi.
Pi over 3. So b would be pi over 3. Can we find a function where we're looking at the cosecant curve with a b of pi over 3? How about over here?
Yeah.
This is the only one. Now, this 2 acts as a vertical stretch factor, but this has got to be that first graph because it's got a period of 6. And this is the only one that has a period of 6. You even wrote a 6 next to it there.
Yeah.
Okay? So, A goes with this one here. So maybe the best way to do this is to go through each of these and figure out what their period is and where they're located. What does B look like? Which graph? Of the 6 trig functions, what does B look like?
I don't think I know it. What do you mean?
Let's go over the tangent and cotangent curves. First I'm going to draw the tangent curve. Tangent curve has a period of only pi, not 2 pi. In other words, it repeats every pi. And it also has vertical asymptotes every pi. And it typically goes, the normal tangent curve goes from minus pi over 2 to pi over 2. It's always increasing. Goes from negative infinity to positive infinity.
Mm-hmm.
So if we found this curve here, we would be looking at y equal tan x. Okay?
Okay.
So, but y equal negative tan x looks like this. Right? I'm just going to take that curve and reflect it over the x-axis.
Yeah.
Well, that negative tangent curve looks an awful lot like cotangent. Let me draw the cotangent curve. The only thing wrong with it is it's not in the right spot. The cotangent curve goes from 0 to pi and has vertical asymptotes every pi. And the cotangent curve looks like this. Always decreasing. In other words, the cotangent curve looks exactly like the negative tangent curve, only it's shifted pi over 2 to the right. So if we see a tangent or a cotangent curve going from 0 to pi, that's cotangent. If we see one of these curves going from minus pi over 2 to plus pi over 2, that's tangent.
Okay.
Okay? So, we're looking at one or the other here. Notice that one period goes from 0, what's that number?
2.
What's this number?
1.
Okay? So the period is 2. First of all, is that going to be tangent? Is that going to be negative tangent or cotangent?
Cotangent.
Okay. So we have a cotangent curve, and we have a period of 2. What is b going to be? B equals pi, not 2 pi, pi over the period. So b is pi over 2. We have any b's of pi over 2 down there that look like cotangent?
5.
5 goes with b. All right. C. Not making these easy, are they?
No.
Well, we drew the cosecant curve. Now let's draw the secant curve. Secant curve sits on top of the cosines, right? Because cosine is the reciprocal of secant.
Mm-hmm.
Okay? So, I start off by drawing the cosine curve, merely because I know what it looks like always. And the secant sits on top of the cosine curve. Top and bottom, like that. So if one of these u's is symmetrical with the y-axis, then it's going to be secant, right? Because if it was cosecant, it would be over here. It would be sitting on the top of the sine curve. So anything that straddles the y-axis is going to be secant. Now, this doesn't straddle it up there, but it straddles it down here. What does that mean?
It means that it's cosecant.
It's negative secant. In other words, it's this curve right here reflected over the x-axis.
Okay.
Okay? For it to be cosecant, it would have to be shifted right or left.
Okay.
So this is a negative secant curve, what we're looking at here. Right here, that's a negative secant curve. Does that answer our problem or not? Let's see. Do we have any negative secants? Right there. Now, I didn't check the period, but the period is going to be from here to here. What is that on that scale? Can we read that? Like 1?
No, 1 is at the very end of the line, so all that in between is less than 1. It doesn't have a number.
Okay. So it's less than 1. It's actually very close to 1, isn't it? If I go from this line right here to this line over here, I'm about that much short. So it looks to me like the period is 1. Well, let's see. If the period is 1, and the period is equal to, is it pi or 2 pi over b?
This is 2 pi.
And if my period is 1, well, let's see, b equals 2 pi over the period, which is 1, so b is 2 pi. So there's that 2 pi right there. I knew it was secant. I knew it was negative secant.
So it's 8.
It's 8 for that one. All right. This one here, what does that look like? What were we just drawing?
I'd say it's probably negative tangent.
Positive tangent. Remember, tangent is always increasing. It's always going from lower left to upper right. The thing that's always decreasing is cotangent. That's the cotangent there. This is tangent, and it straddles the y-axis. Cotangent goes from 0 to pi. Tangent goes from some negative, usually negative pi over 2, to pi over 2. So this looks like tangent. And can we read any of these numbers?
Yeah, it's pi over 2, pi, 3 pi, and then it cuts off.
That says pi over 2?
Yeah, that one's pi. No, that one's just pi.
This one?
The asymptotes are just pi.
Is it negative pi to plus pi?
Yeah.
So what's the period of this function?
Pi.
It's 2 pi. Period is from the starting point to where it repeats again. In other words, it's this distance from here to here.
Okay.
Okay? It looks like if that's pi, then it's going to go 2 pi for a period. Well, if the period is 2 pi and b equals pi over the period, remember we're dealing with tangent, so b equals pi over the period. If the period is 2 pi, then b is 1/2. And remember, a b of less than 1 has a horizontal stretch, which is exactly what's happening to this.
So it's going to be 2.
Uh-huh. Because b is 1/2. Okay? Now, do we have today and tomorrow to cover all of these?
Yeah.
Okay. You want to just keep going through these, or you want to do another section?
Let's go down to the graphing ones.
Okay. We can come back and do those, but I hate to spend our whole hour on that. Okay, good. These are actually easier to graph than they are to come up with the function of the graph. I think, at least. The first thing you want to do is lay out what A, B, C, and D are. I assume that this is your standard. Is that your standard formula?
Yeah.
Or is the B inside the parentheses?
No, it's outside.
Okay. All right. So for this first function, what is A?
It is 2/3.
What is B?
Pi over 2.
C is 0. D is 0. So there's no phase shift to worry about. There's no vertical shift to worry about. It's a cosine curve, so it's going to look something like that. only it's going to go from what to what?
2/3 to 2/3.
Negative 2/3.
Negative 2/3, yeah, sorry.
And what is this point right there going to be?
4.
Let's see. The period is equal to 2 pi over b, and b is pi over 2. Good. 4 is correct. Is there anything else? Let's see. It wants intercepts. Okay. What's this point and what's this point? I see.
So that's 2. Is that the halfway point or the quarter point?
Those are the quarter points.
Oh, 1 and 3.
The halfway point is there always. What you want to do is you want to take your period and divide it up into quarters always. So that would be 1 and 3, or your x-intercepts. Mins and maxes. Well, the minimum minus 2/3, the maximum is 2/3. The quarter points, the domain and range, using this notation. Okay. What's the domain?
All reals.
Okay. What's the range?
2/3 to negative 2/3.
Okay. I think you want to start from the bottom there, always. So the range is negative 2/3 to 2/3. At least that's typical convention. That's it. Let's go to number 2. Let's just start with a cotangent function that hasn't been messed with. Remember, it always goes down, cotangent, always decreasing, and it goes from 0 to pi. That would be y equal cotan x. Okay? So, A is 1/2.
1/2.
We have a reflection over which axis?
The x.
B is what?
4 pi over 5.
Which makes the period remember that
5/4.
pi divided by 4 pi over 5, so it's 5.
So 5/4.
So the period is 5/4. And there's nothing else going on here either. So all right. So what is this mark right here supposed to be? It's 5/4. In other words, that's the period. So this has to show it has to be 5/4. Okay. Let's see. What do they want all? They want the intercepts using this notation. Okay. What are my intercepts? What's this point right here?
That is going to be 5/8.
What's this next intercept going to be?
I don't know.
Well, it's 1 period over. In other words, this next period is also going to have a period of 5/4. So this has to be 5/4 plus 5/4, or 10/4 right there. and it's going to look like that. So what is this midpoint? It's 5/8 plus 1 period. 5/8 plus 5/4 is 5/8 plus 10/8. That's 15/8. So our x-intercepts are 5/8 plus 5/4 times n. Is that the notation you use?
Yeah.
In other words, when n is 1, we're at 15/8. When n is 2, we add another 5/4 to it. We're over there. Technically, I think, I'm not sure exactly how that, am I supposed to put a plus or minus in front of that? Like that?
I don't think, yeah, actually.
It makes more sense because usually when you use n, it means n is equal to 0, 1, 2, 3, 4. Now, if n takes on negative values, I don't need the plus or minus. But if it doesn't, I need the plus or minus because I also have a vertical x-intercept right there, and I have another one 5/4 to the left of that. So in order to cover the positive and negative x-intercepts, I think I need to write it like that. But I'm not sure about that. I don't ever actually remember seeing a plus or minus in front like that. But I don't think n takes on negative values. So if n takes on negative values, then I can just write it plus 5/4 n. All right, let's see. Asymptotes. Where are my vertical asymptotes?
5/4 and 10/4.
Well, x equal 5/4 is certainly this vertical asymptote. I got another one over here and a bunch more. So it's 5/4 plus 5/4 n, plus or minus. In other words, when n is 0, your vertical asymptote is at 5/4. When n is 1, the vertical asymptote is at 10/4, and so forth. So that's the definition for vertical asymptote. Mins and maxes. Does this thing have any mins or maxes?
No.
Quarter points. So what are my quarter points? In other words, I just need to take one period of it. I know I got a lot of scribbling on here, but
The quarter point will be 5/16.
let's see. Do we need just, okay, we don't really need to separate this into quarters. We just need to separate it into halves, I think. But she asked for quarter points, so that's fine. If this is 5/4, then this has to be 5/8. This has to be, why is this not working? This has to be 5/16, and this has to be, let's see, that is 10/16, 5/16, 10/16, 15/16, 20/16. Okay, those are our quarter points. 5/16, 5/8, 5/16, 5/4. Okay. Domain.
I don't know how to do the domain on these.
Domain is the x allowable values. So
Yeah,
if
so
this
all the
curve
numbers
looks
and
like
stuff.
what can x be and what can't it be? In other words, they want you to say x is all reals except x not equal to a multiple of what?
5/4.
Yeah. So I think that's the way she wants you to say it. Now that I'm looking at this, it's x is all reals not equal to
5/4.
a single multiple of 5/4. Not an odd multiple or an even multiple, but a single multiple of 5/4, which is what that says right there. What's the range?
Negative infinity to infinity.
Okay, good. All right. Write a little smaller. A is 4. Reflect over x. And the b is 2, which makes the period what for the cosecant?
Pi.
Okay. So the way I'm going to graph this, first of all, let's just draw in the cosecant. Cosecant is reciprocal of sine, so it's going to sit on top of the sine, so it's typically going to look like this. And this would be 2 pi. Okay? Our period is pi. So that's all I have to do is change that. Now quarter that.
Pi/2.
Pi over 4, pi over 2, 3 pi over 4. Right?
Yep.
Hold on here. Try to make it a little more accurate. Okay. In this case, what's the well, let's see. We've already applied the 2, making it the period pi instead of 2 pi. And the stretch factor of 4 means what? What are these points right here?
Which points?
The y.
Oh, they're 4, -4.
And the consequences of the negative sign. In other words, what I've just drawn is y equal 4 cosecant of 2x. So how do I draw y equal -4 cosecant of 2x?
Flip the graph. Yeah, there you go.
And that's the way you do these. Step by step. Okay. Number 10 typically goes from minus pi over 2 to pi over 2, always increasing, going through 0. So that would be tan x. What's the consequences of the coefficient there? What's b?
B is 1/4.
So what's the period?
Period is pi over 3. Or pi over 4, sorry.
Well, the period is pi divided by b. What's that?
So it'd be 4 pi.
Okay. Which means if my period is 4 pi, this thing has to go from what to what? What is that point and what is that point?
-2 pi, 2 pi.
Quarter it.
Yeah, pi.
Pretty easy to quarter. Now what's the effect of the 3? Almost have it. We got that much of it. On a typical, let's go back a moment. Let me go down a second here. This is a bit strange because this point usually is not put on this graph, but it should be. And the point I'm referring to, in other words, if that's the straight tangent curve, goes from minus 2 pi, or minus pi over 2 to pi over 2, what is the tangent of pi over 4 equal to? What is this value right there on the y-axis? What's the tangent of 45 degrees?
Tangent of 45?
Uh-huh. 1. So this point should always be on there with the number 1 next to it. Well, in our curve, what is it going to be?
3.
Right. So if I go back to our function, the only thing we need to do to make this look like our curve is make this point right there be 3. And then it will have the effect of a vertical stretch. It would be as if you laid out the original tangent curve with a piece of string and you tug on both ends of the string, bringing the point that was at 1 up to 3. And this point here is minus 3. And notice that when I plug in pi, in other words, this point right here, into our function, I get 3 times the tangent of pi over 4. Well, that's 1, so it's 3. So this curve fits this function perfectly.
Okay.
X-intercepts. In other words, let's draw one more period of this. What's this point over here?
4 pi.
Okay. What's this intercept right here?
3 pi.
Okay. So our x-intercepts are 0 plus, or rather 0 comma, odd multiples of pi. Is that how she wants you to write it?
Yeah.
In other words, our intercepts are 0, and then another one at 3 pi, and then another one at 5 pi. So odd multiples of pi are our intercepts. Ooh, hold on. Something's wrong with that. Because let's see, our intercept was 0 there, and then our intercept was 3 pi and 5 pi. Something's wrong. Our intercepts have to be separated by 4 pi. What's going on here? My picture is confusing me, I think, because I drew that thing in the wrong spot. Let me go back here and draw this picture a little more accurately. Let's see. Our first vertical asymptote goes through 2 pi. Our next vertical asymptote goes through 4 pi. So this curve goes through the x-intercepts now I see what I did. I drew it wrong. Remember our period is 4 pi?
Mm-hmm.
So my next
Yeah.
vertical asymptote doesn't come there. My next vertical asymptote comes at 6 pi. And the x-intercept comes at 4 pi. So the x-intercepts are first one's at 0, the next is at 4 pi, the next is at 8 pi, the next is at 12 pi. So the way I would write that would be 4 pi n, I guess.
Yeah.
Can't say odd or even multiples, but 4 pi n, this is accurate for telling you where the x-intercepts are. How about asymptotes? Vertical asymptotes are where? X equals.
X equals negative 2 pi, 2 pi, and 6 pi.
Well, it's actually x equal 2 pi plus 4 pi n. Because you have an asymptote everywhere there. In other words, you have an asymptote at 2 pi, 6 pi, 10 pi, 14 pi, 18 pi, negative 2 pi, negative 6 pi, and that sounds like that to me. Domain. X is a member of all reals except what?
Except, I don't know how to, like, word it.
Well,
I don't know what it
any
is.
place the vertical asymptotes are. X cannot be at any of those vertical asymptotes.
Yeah.
X can be anywhere on the x-axis except for 2 pi, 6 pi. In other words, the same definition of the vertical asymptotes is what X cannot be. So it would be worded the same way. X is all reals not equal to 2 pi plus multiples of 4 pi. Not odd or even, but single multiples of 4 pi. All right. Should we go back and look at some more of these others?
No, go to the next picture I sent you.
Okay.
There's 2 more graphing ones on there that I want to get through.
Okay. Ah, 5 and 6.
Mm-hmm.
Again, I think it's always a good idea to start with the original elementary parent function. Secants the reciprocal of cosine, so it sits on top of the cosine. If that's normally 1, then the secant's going to look like this. Okay? So,
Okay.
A is 2. B is pi over 3. What is the period?
6.
So it's 6 from this, and we got vertical asymptotes. Every pi. And a period. of 6. What's this point right here?
Negative 3/2.
What's this point here? Take your starting point and add 6 to it. Negative
Okay.
3/2 plus the period gives you your end of the period. Quarter that is this point right here. And in fact, what's that? That's 0.
Yeah, 9/4.
So that has to be plus 3/2.
Yeah.
And that has to be another 3/2. The right is, okay, so everything good so far? We almost have the whole curve. What last thing do we have to do? The consequences of the 2. It's that point right there going to be on the y-axis, and this point right here.
2.
And negative 2. That's it. Okay. And let's see if we can get through this one. That's the standard sign. So the only thing that I got to do really here is figure out that point, and this point. We forgot to do domain and range on the previous one. All right, let's go back a second. Well, in fact, we forgot to do a lot of things. X-intercepts.
None.
None, exactly. Asymptotes, vertical asymptotes.
3/2 plus 6.
Now, vertical asymptotes are always an equation of a line. So 3/2 plus 6.
6n.
Is it 6? How far in between our vertical asymptotes? What's the distance from here to here?
1.
It's 3. Minus 3/2 to plus 3/2.
Okay.
Remember, we're not talking about the period of this function. We're talking about the asymptotes.
Yeah.
The asymptotes come every half period.
Yeah.
So if the period is 6, the asymptotes have to come every 3.
Yeah, so plus 3n. Yeah.
So those are your vertical asymptotes. There's no x-intercepts. Domain is what?
Hold on. I'm finishing writing some. Domain is x is all reals except for 3/2 plus 3n.
Right. And range?
Y is less than or equal to -3. Y is greater than or equal to 3. Or not 3, 2. Sorry.
Okay. So, okay. You don't have to do interval notation on that?
No.
Okay. And as long as it's less than or equal to, because it can be -2. And
Yeah.
it can be positive 2. Okay. And you want to go back to the first one? Oh, you want to go to this one here?
Yeah, we never finished 6.
Oh, sorry. I got caught up finishing 5. Okay. So what's the B is 2/3, so my period is what?
3 pi.
means is all I have to do is label that 3 pi. And label this what?
Hold on just 1 second. Alright, what was it?
What's
What
the
you
y
ask?
value there?
The y value is 1/2.
And minus 1/2. And quarter this.
3 pi over 2.
It's the middle one. So this has to be what?
3 pi over 4.
This
And then 9 pi over 4.
What else do we need? X-intercepts.
3 pi over 2 and 3 pi.
Plus what?
3
How
pi over, be plus 3 halves. And
let's see, when n is 0, the intercept is 3 pi over 2. Well, why don't we just write it like this? Because what we really want is when n is 0, our x-intercept is 0.
yeah.
And then when n is 1, our x-intercept is 3 pi over 2. When n is 2, our x-intercept is 3 pi. So that works perfect. Just like that. No number in front. In other words, you want to allow for the 0 one. We weren't allowing for the 0. I guess if I said that n was -1, that would allow for the 0. But I don't know why you would write it any way other than this. Domain?
Domain is all reals.
Range?
1/2, -1/2 to 1/2.
Okay. That's everything, right? For 6. Okay, so you want to go back to part 1 or you want to look at part 3? We only have like 5 minutes, but let's do the first one of 3. We haven't, is that the same as the other? Actually, well, the other's a multiple choice. Let's do this one.
Yeah.
I think this is more valuable to you, to read a specific graph and come up with the equation of that graph. We got time for just about to do 1 here. Okay, so what can we say? Let's see if we can figure out our letters. What is A?
3
What kind of curve is this, first of all?
sign. Negative sign.
Negative sign. So we're looking at something that's going to look like negative A sine, and then we'll fill in the rest of BX. So what's A?
3.
What's B?
The
First we need
the period looks like it's 8 pi, so the period would then be 1/4.
They're pretty tricky, leaving off the pi there.
Yeah.
Okay, so the period is 8 pi, B is 2 pi over 8 pi, 1/4.
So 1/4.
So what's my equation?
-3 sine 1/4 x.
Okay. And find the domain and range. You don't have any problem with that, especially on sine.
Yeah.
The only
We
difficulty.
have time for one more, actually.
Yeah, we do. We'll do this one. The only difficulty on domain and range is with these ones that have the vertical asymptote, and only because you have to define it in that screwy way. It's not a screwy way, but it's just a different way. So let's see. What is A here? What's this curve, first of all?
This curve looks like it's going to be secant.
Negative secant. Notice that the secant would start there and then go there. The secant is going to sit on top of the, cosine. Hold on, this is cosecant. Negative cosecant, right? Yeah, no, hold on. Now I'm confusing myself. This is negative secant. Notice that sine secant right?
Yeah.
In other words, the positioning of this thing is that positioning only reflected over the x-axis. So it's a negative cosecant curve. What is A?
3/4.
What is the period?
Period. 6/8. Or so.
Twice that. 12/8. You see why? In other words, it goes
Yeah, I see it. Yeah, I see it now.
from there to there is 6/8, but that's only half a period. The whole period goes from there to there. So it would go from minus 6/8 to plus 6/8, which is 12/8. So B is
4/3 pi.
okay. So my equation is what?
Negative 3/4 cosecant 4 pi over 3x.
No x-intercepts. Well, they don't even ask for them here. Domain and range. What is the domain? That is at 6/8. Vertical asymptote. What's the domain? That's all they want.
Domain is XER except multiples of 3/2. Is that right?
3/4. In other words, this is 3/4. This is 6/4. So every 3/4, you have a vertical asymptote. So when n is 0, you got a vertical asymptote right there. When n is 1, you got a vertical asymptote at 3/4 or 6/8 right there.
Mm-hmm.
So forth and so on. And finally, the range.
Y is less than or equal to 3/4 and y is greater than or equal to 3/4.
Okay, it's less than or equal to negative 3/4 and
Or yeah, negative 3/4.
greater than or equal to positive 3/4. All right. And that's that.
All right.
That one might be one you want to watch the recording on. I'll try to get this recorded or processed tonight so it'll be up there first thing in the morning. I don't know if that'll help you or not. But it actually will if your test isn't until Tuesday.
Yeah.
But we're meeting again tomorrow night, so we can probably solidify this information and knowledge. All right, Jackson, I will talk to you tomorrow. Let's see, what time is the session tomorrow?
I think tomorrow's at
8.
8, honestly.
Yeah, it is.
All right.
Talk to you then.
All right. Thank you. See you.